length. Okay, this is it. X equals 0, spring constant is k. And what is the state of block? From rest to rest will be moving it. Now extra agent will come. He will move the block through a distance x. Next, he will further move it through a distance x. Further, I'm telling further. Next, he will move the block okay, we have three situations. So first, there was no, it was at main position the block. Now the extra agent has to do work from this position to this position W1, from this position to this position W2, from this position to what is energy stored in the spring? U1, U2, U3. It was first I'll elongate by x. Then further I'll increase the elongation from x to 2x. Then from 2x to 3x. Whatever the energy stored in the spring, then we'll calculate the work done also. Then we'll see how they are basically related. So what is the energy stored in the spring U1? U1 should be equal to kx squared by 2. What about U2? What is the total elongation? 2x. So 2x squared by 2. So this will become 4 kx squared by 2. What about U3? K 3x whole square by 2. So this will be 9 kx squared by 2. So what is the ratio? U1, U2, U3. This should be equal to 1:4:9. When it is elongated by x, if energy is U, when it is elongated by 2x, how much of energy will be 4 times? When it's elongated by 3x, how much of energy will be 9 times? The simplest idea. Now what about work done? How to calculate? So W1 should be equal to U1. How to get the W2? Work done extra agent in elongating. So now who is he? Is an external agent, no? What is W1, W2, W3? W1, W2 and W3 are work done by an external agent. How work done by extra agent and change in potential are related. Work done by extra agent should be equal to plus delta U. So W2 should be equal to U2 minus U1. Negative sign, shall I keep it? Anybody?
No,
work done by spring force should be minus delta U. Work done by extra agent should be plus delta U. So final minus initial. So therefore we don't know U, like a U2. U2 is how much? 9 kx square by 2. U1 is how much? Kx square by 2. How much it is? 8 kx square by 2 or 4 kx square, you can write it.
sir, U2 is 4
U2,
K.
U2,
There
U2,
U2 is 4.
4, 4. I'll make change. Yeah. Now similarly W3 will calculate. Extra agent has to pull this block. You have to do work. No, see, elastic band. You try to stretch it. You have to do work for that. The elastic band on its own, you have to spend some energy. Work done by you, no way it is soluble. Convert into increase in elastic potential of spring. So this will be U3 is how much? 9 kx square by 2, 4 kx square by 2. This will become 5 kx square by 2. What about W1? This should be equal to 1:5:9. Where you will be doing more work?
Sir, 1:3:5.
1:, okay, I'm seeing some other way. Yeah. When you are, if you want to elongate by x, I think you have to do just work, say suppose say 1 joule this is. If you want to further elongate by x, you have to do more work. Any reason? Because the spring force is more, no? You have to encounter more opposition by spring force. You have to do more work here. So already it elongated by x. If you want to further elongate, you have to do more work. Just to elongate x, if you do work kx square by 2, to elongate from x to 2x, you have to do 3kx square by 2, 3 times of that initial energy stored in the spring. So when stretching a spring will be easier. When it is the natural length, stretching it by distance x will be easier. When it is already elongated by x, if you want to further elongate by x, you have to do more work. 3 times of that one. Already elongated by 2x. If you want to further elongate by x, you have to do 5 times of kx square by 2. So when elastic band, stretching will be easier. When it is a natural length, you can easily stretch it. When already stretch it, if you want to further elongate, no, you have to do more work. That's what he mean to say here. Okay, this is some sort of work done. I brought it, and we have other side the spring force also acting. So how that spring force and the elongation, the area under fx graph should be equal to work done. So can we relate those things in this area? That's what we are trying to do now. We'll take one graph. Okay, like this we have spring force kx, 2kx, 3kx. This is about the spring force. This is about the elongation x, 2x, 3x. Now I'm interested in this particular strips here. Very small, very interesting discussion. This is again going to help us a lot in numericals here. So are you seeing some area, different colors, areas, what we have? So what is this area of this triangle? This should be equal to U1. Okay, we'll give a better name. We'll give it. So this is O, A, B, C, D, E, F. We have to correlate with the things what we have learnt. I think I have. We have to indicate all that W1, W2, W3 and also that U1, U2, U3 in this particular graph. You have everything in that one. So what about the I think most of you are able to see the complete diagram, everything. What is this W1, W2, W3, all this one? Where to indicate that W1, W2, W3, W1, W2, W3, U1, U2, U3 all. OA, triangle OA. Look at triangle. Triangle OAB, what it should be equal to? U1 as well as W1, no? What is the reason for that? Because area under fx graph should be worked done. And the first case, how much of I do work, that will be energy stored in the spring. So W1 is in fact equal to U1. What about the triangle OAC? Area of triangle OAC. So OOCD. OCD. There is energy stored in the spring. So what is U2? U2 should be area of triangle OCD. What about W2? W2 is already there is energy is there, and I'm going to further elongate it. So area of this trapezium is what? W2. Area of trapezium ABDC. Now what about U3? U3 should be equal to area of triangle OEF. What about W3? W3 is area of trapezium CDFE. U1, U2, U3, W1, W2, W3. All these things is what we have brought it here. Area under fx graph should be the work done, and here work done is nothing but energy stored. So like this we can express all these things. So already there is energy U1 is there. I want to make the spring energy U2. For that I should do this much of work. So this pink color one, what we can write? You can write this as U1 and U2. U1 and W1. What about this? You should not write U2. U2 means this total bigger triangle. So this can be written W2. This is W1, W2, W3. Let me write it here. Okay, so if you are getting confusion, you can take help of these triangles. I think not advisable. Better to stick on to the basic formulas. They are going to help you. Okay, there's a basic idea of the springs. Okay, now we have to explore the numericals related to the spring, that one. Make observation. Will take some numericals. Let me have water. Let's go for, suppose say if we have how to apply conservation of mechanics. This is very important because spring force is a